Hi to all. Up to now in engineering electromagnetics, in electrostatics chapter, we discussed about electric potential, that is potential gradient. After that, we discussed about what are the applications of Gauss law. After that, we go for Maxwell's first law and numerical problems. The syllabus regarding unit 1 is electrostatics. The unit 1 is, now we go for Maxwell's first law and applications of Gauss law and numerical problems. After that, we go for Laplace's and Poisson's equations, solution of Laplace's equation, electric dipole and potential due to electric dipole, torque on electric dipole. Like that we go for in electrostatics. The application of Gauss law. What is the application of Gauss law? That is used to obtain d bar and e bar. The application of Gauss law is to obtain d bar and e bar in different charge distributions. Now we go for Gauss law applications, another application, that is uniformly charged sphere or a sphere of radius. For that, how to apply the Gauss law. What is the application of Gauss law? Alternatively, the Gauss law can be used to obtain d bar and e bar. D bar and e bar. The Gauss law can be used to determine the d bar and e bar, that is electric flux density d bar and electric field intensity E bar can be found by using Gauss law. What is the Gauss law? From Gauss law, Q equal to surface integral d dot ds. D dot ds is the Gauss law. Surface integral d dot ds, we can apply the Gauss law. This is the Gauss law. To how to find d bar, the d bar and e bar can be calculated by using Gauss law. What is the application of Gauss law? Mostly we are using the Gauss law to find the total charge. Total charge equal to surface integral d dot ds. It is the Gauss law, main Gauss law. Now what are the steps required to find d bar and e bar are? First we have to identify d bar direction. D bar direction, that is magnitude of d bar and its direction. That is the first step. Steps to obtain d bar and e bar are: identify d bar and its direction. Second one is identify ds, that is magnitude of ds. Identify ds bar and direction normal to ds and direction normal to ds. After that we have to consider taking the dot product. Third one is, after finding the ds and d bar, take the dot product d dot ds. The third step is take the dot product of d bar and d dot ds. We have to consider the dot product. Now after that we have to choose the Gaussian surface. After that, the Gaussian surface, what is Gaussian surface? Where we are applying the Gauss law. Choose the Gaussian surface. After that integrate. Next point is, after that integrate over the Gaussian surface keeping d bar is unknown. That is integrate over the Gaussian surface keeping d bar is unknown. After finding the charge, d bar is unknown as it is. Next point is, what are the steps required? Is sixth step is find the charge q enclosed by the surface. Find the charge enclosed by that surface. Find the charge q enclosed by that Gaussian surface. After that, after finding the charge, if you equate, seventh one is, after that equate the charge q to integration obtained with d bar is unknown. The charge q is integrated, q equal to surface integral d dot ds. After that equate charge to integration obtained with d bar as unknown. After that we have to go for determine the d bar. If you know q, if you know ds, then you can calculate d bar easily. Now we can determine d bar from this equation. After that, if you want to calculate e bar is already relation between d and e is d by epsilon naught. D by epsilon naught if you use, then you can calculate from d bar, you can calculate e bar. These are the various steps required to find d bar and e bar using Gauss law. Now what are the steps you can see? The first step is identify d bar and its direction. D bar and its direction. After that identify ds, the surface we have to identify, and direction normal to the ds, and direction is normal to ds. ds normal direction is ds, the direction to the normal. After that we have to go for dot product of d dot ds. That is the another step is take the dot product between d dot ds. After that we have to choose the Gaussian surface, where we are applying the integration totally. After that integrate the over the surface as a Gaussian surface, keeping d bar is unknown. Keeping d bar is unknown as it is. Now find the total charge. Find the charge q enclosed by Gaussian surface. Q we have to find out. After that equate the charge q by using Gauss law equation. In this unknown term is d bar only. In this d bar is the unknown term. After that we can calculate d bar and e bar. These are the steps required. Now we go for one example how to calculate the electric field intensity or electric flux density in a sphere of radius r. For a sphere of radius r, assume that a sphere of radius r, that is assume that it is the radius of the sphere. A charge q is located inside of the sphere. A charge enclosing the sphere is q. The charge q is enclosed in a sphere having radius r. For a sphere of radius, let r be the radius of the sphere. R is the radius of the sphere. Let r be the radius of sphere. And electric flux density d bar and e bar we are calculating for the sphere. Let the Gaussian surface is sphere of radius. A sphere is the Gaussian surface we have to assume. The steps what we discussed previously, all the steps we are applying for this to find the electric flux density or electric field intensity due to a sphere. For a sphere of radius r, the electric flux density d bar in radial direction, electric flux density d bar, assume that d bar is in radial direction, it is always ar. Assume that spherical coordinate system we have to assume. What are the spherical coordinate system coordinates? R phi theta, r theta phi, that is the spherical coordinate system coordinates. For example, let d bar equal to dr. Therefore the electric flux density d bar can be written as, consider a sphere of radius r. This is the radius in spherical coordinate system. The charge enclosed in the sphere is q. Assume that the charge is located inside of the sphere, it is q. The flux density d bar in radial direction, that is ar, always assume that. Therefore the electric flux density d bar can be written as dr. D bar can be written as dr. Therefore electric flux density d bar vector, electric flux density vector can be written as dr ar. Ar is the direction. Assume that it is a spherical coordinate system. Sphere, it is spherical coordinate system we have to consider. That is dr equal d bar electric flux density vector is given by dr and ar, dr ar. Make it as equation 1. After that, let the Gaussian surface is sphere of radius r enclosing a charge q. While for Gaussian surface, that is sphere of radius r, ds normal to ds, assume that it is a Gaussian surface, ds normal to ar is, ds can be written as ds in spherical coordinate system. What is the ds in spherical coordinate system? ds equal to r square sine theta d theta d phi ar. Assume that a spherical coordinate system we have to assume. A differential surface, if you assume the differential surface, if you assume that it is a differential surface, here is the normal vector, that is the right angle to the differential surface. ds can be written as, in spherical coordinate system, r square sine theta d theta d phi, it is a d phi, and er. Therefore d dot ds can be written as, for spherical coordinate system, first we assume that d bar is the vector and dr er we can write ds d bar as. That is the first step. After that we have to in the previous second step is identify ds and direction to normal to ds. ds can be written as, in spherical coordinate system, r square sine theta d theta d phi ar. That is that. Now we are substitute that, take the dot product of d dot ds. D dot ds dot product is, we can substitute this dr, equation 1 we are substituting dr ar dot r square sine theta d theta d phi ar. Okay, the third step we followed already. I told you what are the steps required. The third step is, take the dot product of d dot ds. ar dot ar is 1, we can write, since ar dot ar is 1, since ar dot ar is 1, ax dot ax is 1, similarly we can write ar dot ar equal to 1, hence it becomes 1 ar dot product, that equal to dr r square sine theta d theta d phi. Make it as equation number 2. Assume that it is a equation number 2. Simply we are applied third step, that is take the dot product of d dot ds. Now integration will be carried out for the sphere over total integration. That is the fourth step is, choose the Gaussian surface is sphere, spherical coordinate system we have to consider. After that we have to integrate over the surface chosen as a Gaussian surface, keeping the d bar is unknown as it is. That is the third point. Now we are applying integrating over the surface of the sphere of constant radius r. Now integrate over the surface of sphere of constant radius r. That is, therefore we can write as surface integral d dot ds, surface integral d dot ds equal to, what are the limits in spherical coordinate system that we have to apply? Phi equal to 0 to, integral phi equal to 0 to 2 pi. While discussing the spherical coordinate system, I told the limits, what are the maximum upper limit and lower limit, the range of variables, that is phi equal to 0 to 2 pi and theta equal to 0 to pi, and simply we are substituting the equation to dr r square sine theta d theta d phi. We are substituted that. Now apply the limits over the integration. Now first we are applying the phi is integral 0 to 2 pi, and we are applying for entire this. After applying that, what we can obtain, dr r square sine theta, we are applying sine theta, the limits are theta equal to 0 to pi, theta equal to 0 to pi, sine theta integration is minus cos theta, the limits are 0 to pi. After that d phi, the integration of d pi is phi, the limits are 0 to 2 pi, we can apply the limits. From this, if you apply these limits, dr r square if you apply the limits for cos theta, the limits are 0 to pi, then what you will get finally, 4 pi r square dr, 4 pi we can get, 4 pi, the if you apply this 4 pi, if you apply the theta 2 pi and 2 pi 4 pi, we will get 4 pi. Finally we can write 4 pi r square dr. We can write like this, 4 pi r square dr. But next step is we have to equate the charge, q to integration. For this integration we have to equate. Now we applied the Gauss law, surface integral d dot ds equal to q. Therefore q equal to 4 pi r square dr. Already we obtained this 4 pi r square dr. Now dr is given by, from this equation dr is given by q by 4 pi r square, and hence d bar can be written as, what is d bar? Already we told you d bar equal to dr ar. Hence we can write dr is q by 4 pi r square and ar direction. If you, after calculating d bar, we can calculate e bar also. That is the application of Gauss law. To find e bar and d bar, after calculating d bar we can calculate e bar. Now e bar is, what is the relation between d and e? E bar equal to d by epsilon, or d equal to epsilon naught e, d bar by epsilon. We calculated d bar, that is 4 pi r square ar. Now if you substitute in place of d bar q by 4 pi r square ar, then you can calculate e. This is the equation already we obtained by using Coulomb's law. It is the same formula, e bar equal to q by 4 pi r square ar. This is the use of Gauss law to obtain d bar and e bar for a given charge distribution. Okay, in this way we are finding d bar and e bar by applying the Gauss law. Let us see what are the steps involved for a sphere of radius r, how to calculate d bar and e bar. Again repeat that. First we consider that, let a sphere of radius r having a charge q, total charge inside of the sphere is q. After that the radius of the sphere is r. The flux density d bar in radial direction is ar. Always let d bar can be written as dr. Therefore electric flux density vector d bar can be written as dr ar. Make it as equation number 1. After that, let the Gaussian surface is ds. The second step is identify the ds and normal to ds also. Here we are considering spherical coordinate system. What is ds in spherical coordinate system? Differential surface is given by ds equal to r square sin theta d theta d phi ar. Now take the dot product. The third step is take the dot product, d dot ds equal to, if you substitute d bar and ds, then ar dot ar equal to 1. Finally we obtain dr r square sin theta d theta d phi. That is equation 2. Assume that it is a equation 2. After that, what we have to integrate over the surface by applying the limits integrate over the surface. Let us see that. Now we are applying the integration over the surface. Surface integral d dot ds equal to integral phi equal to 0 to 2 pi and theta equal to 0 to 5. Now we substituted d dot ds here. D in place of d dot ds we substituted. It is the Gauss law. D in place of d dot ds is dr r square sin theta d theta d phi. From this, if you apply the limits, integration over the sin theta is minus cos theta. The limits are 0 to 2 pi and it is also 2 pi you can obtain. After that 4 pi you will get 4 pi r square dr. After that we have to equate the charge q. Now we integrate over the surface d dot ds equal to q, integrate. That is q equal to, from this equation q equal to, already we obtained this one, d dot ds 4 pi r square dr, q equal to, therefore dr can be written as q by 4 pi r square. This is the dr. From this d bar equal to dr ar, that equal to q by 4 pi r square ar. Similarly we can calculate e bar. If you know d bar, we can calculate e bar. E bar equal to q by 4 pi epsilon naught r square, ar. This is the expression is same as obtained in Coulomb's law. While we discussed about Coulomb's law, electric field intensity can be calculated as same equation, Q by 4 pi epsilon naught R square. Q by 4 pi epsilon naught R square we obtain. Like that integration we can use to obtain the Gauss law.